Alrighty, howdy folks. Chapter 4, Section 4. We are continuing with our comparing alternatives. This is about another method called discounted payback period. So let's get right onto it. Definition: the discounted payback period DPBP for an investment is the length of time required for the cumulative present worth to become positive using I equals minimum attractive rate of return. Okay. So for different uh, payback, what is that? For an investment length of time, right? If you change n, would you agree that the present value keeps changing? Let's say you got some benefits and all that stuff. Depending on how many years that is, the present value is going to change. So, what is the present uh, worth? What is the number of years for which this project should be run so that the present worth becomes positive? One thing is clear: the present worth would be negative to begin with because you would have incurred a big cost because of taking up the project, but then you'll start to see benefits starting year one. Okay, 1 year, 2 years, 3 years, even if you got some benefits in say 1 and 2 years, you look at the present worth, it would be less negative but not quite positive. Would you agree with that? You invested some money, you got some money first 2 years, so you are slightly less negative. But then, if you keep receiving benefits, at some point of time, your benefits will outweigh the cost so that the net present worth will actually become positive. What is the time period? That is the discount payback period. Okay? With an example, it should become a little more clear. Let's look at this. A firm wants to buy a machine that has first cost of $100,000 and a useful life of 15 years. At the end of its useful life, the machine has no salvage value. Okay. Labor costs would increase $2,000 per year using the machine, but raw material costs would decrease $12,000 per year. And the minimum attractive rate of return is 5% per year. What's the discounted payback period for this investment? Right, that's the first question. And if the maximum attractive DPBP, discounted payback period, is 3 years, what is the decision rule for judging the worth of this investment? Should the firm buy the machine based on DPBP? That's the third question. So let's look at this. First cost is $100,000. Useful life is 15 years. Okay, that's fine. At the end of its useful life, the machine has no salvage value, so we don't need to worry about that. And labor costs would increase 2000, but raw material costs would decrease. So there is a benefit of 12,000 minus 2,000, that is $10,000 per year is the benefit. Would you agree? So that is like getting money. That's a uniform distribution of $10,000 per year. Now, for how many years? Do not say 15 because that's the useful life of that. The truth is, we don't know for how many years, right? And that's going to be a variable n. With that, we are in business. Um, ooh, yeah, I think am wrong here. I shouldn't say all the way up to 15. It's only up to n. Yuck. Let me fix this. This should be n, and this should be n minus 1. Oh, Save it. I'm sorry. Okay, so now DPBP is n years, so present worth. Clearly, minus 100,000 at t equals 0. And the benefits are $10,000. And because it's a uniform series occurring all the way up to from 1 through n years, project it back using our good old formula. And the present worth should equal 0. But I thought you said it should become positive, man. Yeah. From negative, as it's going to become positive, would it have to cross 0? So that's what we do. We set it equal to 0. Because anything beyond that, if you continue to receive benefits going beyond this n, of course, the present worth would become positive, right? All right, let's see. And so, what do we do here? Some math. I think the only problem is just a little bit of math, I suppose. So we need to find n. So in order to find n, I'm trying to figure out everything inside the square bracket, what is that equal to? So I add, this should equal 0. So I add 100,000 to both sides and then divide both sides by this 10,000, right? And that should give me this factor. Cool. 100,000 divided by 10,000 is 10. Now the question is, how do we find n? So luckily, this is 1.05 to the n, and this is also 1.05 to the n. So kind of like think of it as x minus 1 over 0.05x. That is equal to 10. Can we not solve for x, right? So that's the strategy I'm adopting. So when I say 1.05 to the n, that is the top, I added 1 to both sides, so became 1 plus. Now, if you cross multiply 10 times 10 times 0.05 is 0.5 times 1.05 to the n. That's how I got this. Now, let's solve for 1.05 to the n by subtracting this guy from both sides. And so factoring out a 1.05 to the n, we get 1 minus from this 0.5, 1 minus 0.5, and that should equal 1. And so 1.05 to the n would be 1 over 1 minus 0.5 is 0.5. So 1 over 0.5, which is equal to 2. If 1.05 to the n equals 2, n should be log base 1.05 of 2 or log 2 over log 1.05, right? Change of base formula. That turns out to be 14.21 years. Cool. The discount payback, therefore, is 14.21 years. Uh, let's pause for a second. Good, bad, indifferent? What is the idea? The idea is the useful life is 15 years. And apparently, if this project runs for 14.21 years, well, that's good, right? So, in a way, this is not bad. But what is the second rule? If the maximum attractive DPBP is 3 years, so what the management want is we should start seeing benefits right after 3 years. The present worth should become positive in 3 years. If it takes more than 3 years, nah, we don't want it. If it's less than 3 years, yeah, awesome. Maximum it should take 3 years. That's the stance of the management, and that's reasonable. And so what should we say? Well, this DPBP is 14.21 years. So this particular machine apparently will give you benefits only after 14 years of running it. Management wants it less than 3 years, equal to or less than 3 years. So the project is go only if it is if its DPBP is less than 3 years. And so sadly, 14.2 years for this option. So do not do the project. That is, no. Should the firm buy the machine based on DPBP? The answer is no. Don't do that. Cool. All right, that's a good example. Now let's look at another one. The expected cash flows of options A and B are shown below. Minimum attractive rate of return is 8% per year. What's the discounted payback period for each option? Which option should be chosen to minimize the DPBP? Minimizing a DPBP is always a good idea, right? You're getting your money's worth. You're starting to see benefits become positive, the present worth of benefits become positive after certain very quickly, right? That means if DPBP is small, that means you are recovering positive things at a shorter period of time, in a shorter period of time. That's what I wanted to say. Cool. Numbers. And when things are given in tables, it makes laugh so simple. Initial investment, that's a cost. End of life salvage, yeah, that's a benefit. It's a positive in the cash flow. Annual income, yeah, positive. Annual expense, negative every year, right? Annual every year. Cool. So, I don't know. Do we really need to draw a cash flow diagram? If you want to, please go ahead and do it. So, DPBP is N sub A for this option A. I don't know. How many years should we run this to see positive? We don't know that, so that's a variable. And now for option B is N sub B. So for present worth of option A, stands to reason you have a negative 50,000 corresponding to the initial investment, and benefit annual income minus expense, that is the uniform thing, and we are projecting it to the for to t equals 0, a whole bunch of them. And then finally, the salvage value is a final thing at n sub a. So we push that back to t equals 0 by dividing by 1.08 to raised to n sub a, or multiplying by 1.08 to the negative n sub a, right? And all of this we are setting equal to 0. Okay, now the math. Yeah, adding $50,000 to both sides. That's why you don't see a negative 50,000. You see that here as a positive 50,000. And this minus that is 9,400. And then, check this out. Wait, why didn't I do that earlier? Huh, right? We can split this into two fractions, right? 1.08 to the n sub a over this minus 1 over this. So when you do that, they cancel. So that you just get 1 over 0.08 minus 1 over 0.08 times 1.08. Yeah. Huh. Plus 10,000 over 1.08 and sub a. And so we manipulate that a little. We factor out a 1.08 and a and add and subtract and plug and chug, and that gives you 1.08 to the raised to n sub a is this. And so use logarithms and calculate n sub a to be 6.0467. Okay, good. So for option A, what is the idea? The discount payback period apparently is 6.0467 years. Estimated life is 10 years. So you take up this option, right? What's going to happen? You will recover, you'll start to see positive benefits in 6 years itself. And so for the seventh, eighth, ninth, and 10th years, you are just making money. Cool. So this looks like not a bad idea at all. Discount payback. Since this is less than the estimated life of 10 years, option A is a possible choice. Yeah, this is a this is not a bad choice. This is a possible one. Cool. Let's do a similar analysis for option B. Like a good boy, I copied the table so we can actually look at this. Minus 80,000 and the benefits at 26,000 minus 6,000, right? Income minus expense. And then the same thing, but raised to n sub b. And if we do this, oh, that's the advantage of this one. The previous one had a little complication with a life salvage value of 10,000, but this is zero, so there is no additional term. Okay, and if we do this and do the math, that turns out to be 5.0111. So discount payback period is 5.0111 years. Should we do this or not? Notice for option B, the estimated life is only 5 years. And so, if you will see only positive cash flow after 5.011 years, then this is definitely not a good idea, right? Is greater than the estimated life of 5 years. Option B is not a possible choice, right? Ladies and gentlemen, that's about a discounted payback period way of analyzing the options. Cool. Is a supplemental method. It is not solely depended on. You should not depend on this method. It's just an extra way of making decisions. Okay. Quite possibly as an engineer, you may need to, in order to convince your bosses, you may need to present both things. If you were to do that, yeah, they'll be like, yeah, attaboy, good job. Amigos y amigas, adios.